Humans have always questioned the origin of the universe. This fundamental inquiry transcends scientific interest, touching philosophical and even theological dimensions. Throughout history, different civilizations have proposed various cosmological theories and myths to explain the cosmos's creation. These stories reflect their unique cultural and spiritual understandings. From ancient Greek mythology to Hindu cosmology, each culture has its own narrative, illustrating the universal human desire to understand our beginnings. In modern times, this quest has evolved into a scientific endeavor, grounded in physics and astronomy. The development of theories like the Big Bang has shifted the discussion from mythological narratives to empirical evidence and mathematical models. Scientists now use advanced technology to explore the universe's origins, seeking answers in the stars. Yet despite advances in scientific understanding, the origin of the universe remains profoundly mysterious and intriguing. This topic continuously inspires both awe and further questioning. As we uncover more about the cosmos, the quest to understand where it all began remains an enduring and captivating journey. The Big Bang Theory is supported by detailed observations and measurements. One of the most compelling pieces of evidence is the Cosmic Microwave Background, or CMB. Satellites like COBE, WMAP, and Planck have measured slight fluctuations in the CMB, known as anisotropies. These fluctuations represent the seeds of all current structures in the universe. Additionally, these measurements have refined our understanding of the universe's age and its constituent components: dark energy, dark matter, and ordinary matter. Another critical observation is the redshift of galaxies. Edwin Hubble's discovery that distant galaxies are moving away from us provides direct evidence of the universe's expansion, suggesting it was once much smaller. Inflationary cosmology addresses several key issues in the Big Bang Theory. One such issue is the flatness problem, which questions why the universe appears flat. Inflation proposes a rapid expansion that smoothed out any initial curvature. Another issue is the horizon problem, which asks how different parts of the universe have the same temperature despite being too far apart to have exchanged light. Inflation solves this by suggesting that these regions were once close together before the rapid expansion. During inflation, tiny quantum fluctuations were stretched to macroscopic scales, forming the basis for the large-scale structure of the universe. These fluctuations are visible in the CMB as temperature variations. The steady-state theory, proposed by Fred Hoyle, Thomas Gold, and Hermann Bondi in the late 1940s, offers a different perspective. It posits a creation field, or C field, responsible for the continuous creation of matter as the universe expands. This theory suggests that the universe has no beginning or end and remains constant over time. However, the discovery of quasars and radio galaxies, which appear only at great distances and therefore in the past, contradicts this theory. These observations suggest an evolving universe, challenging the steady-state model. Despite its initial appeal, the steady-state theory has largely been set aside in favor of models that account for an evolving universe. The concept of a multiverse introduces the idea of multiple, possibly infinite, universes. Different theoretical frameworks suggest various types of multiverses. Some propose universes with different physical constants, while others suggest universes emerging from black holes or from eternal inflation, creating bubbles of distinct universes within a larger multiverse. The anthropic principle often comes into play here, suggesting that our universe's constants are as they are, because if they were different, sentient life capable of observing them would not have developed. This principle helps explain the fine-tuning of the universe, offering a philosophical perspective on why our universe appears so uniquely suited for life. String theory offers intriguing implications for cosmology. One of its key propositions is the existence of extra-spatial dimensions beyond the three we experience daily. These additional dimensions are compactified on very small scales, making them difficult to detect. Another fascinating idea from string theory is the concept of brain-world scenarios. In these scenarios, our observable universe might be a three-dimensional brain within a higher dimensional space. This could allow for interactions with other brains, potentially leading to phenomena like inflation or even cyclic universe models. These ideas push the boundaries of our understanding, offering new ways to think about the universe's structure and origins. cyclic or ekpyrotic models propose a universe that undergoes periodic cycles of destruction and rebirth. One mechanism involves the collision of brains, which could cause these cycles. These models aim to address some of the problems of standard Big Bang cosmology, such as the singularity and fine-tuning issues. By proposing a self-renewing universe, cyclic models offer a way to think about the universe that avoids some of the pitfalls of a single, one-time creation event. While still theoretical, these models provide a fascinating alternative to traditional cosmological theories, suggesting that the universe may be far more dynamic and cyclical than previously thought. Understanding the universe's origin extends to questions about the origin of life itself. Studies in astrobiology, which combines aspects of biology, chemistry, and physics, aim to determine how life began on Earth and under what conditions it could arise elsewhere. The processes that lead to planet formation also contribute to our understanding of potential life-hosting environments. Observations of exoplanets and protoplanetary disks around young stars help scientists piece together this complex puzzle. By examining these celestial bodies, researchers can infer the conditions that might support life. This multidisciplinary approach not only helps us understand our own beginnings, but also guides us in the search for life beyond our planet, offering a broader perspective on our place in the cosmos. The search for extraterrestrial intelligence, or SETI, focuses on detecting signs of intelligent life beyond Earth. Using technologies like radio telescopes, scientists listen for signals that could indicate the presence of advanced civilizations. This quest is complemented by exoplanet research, which studies planets outside our solar system to understand which might be habitable or even inhabited. The Kepler Space Telescope and missions like the Transiting Exoplanet Survey Satellite, or TESS, have expanded our knowledge of potentially habitable exoplanets. These efforts are crucial in addressing the age-old question: are we alone in the universe? By identifying planets with conditions similar to Earth, we inch closer to discovering whether life exists elsewhere. The anthropic principle considers that the universe's fundamental parameters are finely tuned to allow the emergence of observers like us. This raises philosophical questions about the nature of the universe and our place within it. Theories suggesting multiple universes might help explain the fine-tuning of physical constants in our universe. If there are countless universes, each with different laws and constants, it might not be so surprising that one of them has the right conditions for life. These theoretical implications challenge our understanding of reality and push the boundaries of scientific and philosophical thought. They invite us to ponder the broader context of our existence and the potential for other forms of life. Philosophical inquiries often focus on the significance of human life within an immensely vast universe. These discussions encompass existential reflections on meaning, purpose, and our responsibilities as a potentially unique or rare form of conscious life. As we learn more about the universe and possibly other life forms, we also have to consider the future trajectory of human civilization. This includes space exploration, planetary protection, and the ethical treatment of any forms of life we might encounter. The quest to understand the universe's origins is not just about filling gaps in our scientific knowledge. It's also about exploring fundamental questions about life, existence, and the cosmos. Such exploration is essential for expanding our perspective and fostering a deeper appreciation for both the universe and our place within it.